Hello and welcome to week 10. Just had a couple of things I wanted to talk about as far as the test and then the material coming up this week. The tests look pretty good. Like I said in my email, I dropped that last concept question. Look at my solution. The question is not identical to what I asked you in your concept discussion, but it's related. It's also on trig substitution and how when you do a trig sub, you're really introducing a new variable. That new variable is theta, and theta is defined as an inverse trig function. So that puts limits on what theta can be. So that then limits what cosine can be, and therefore why we don't need the absolute value at all. There's no need to restrict the domain. Unlike the question that we had in the class discussion, which dealt with secant, there you have to add on that x greater than a. For the substitution x equal a sine, there is no need to add any domain restriction. So look at my solution, but again, I made that extra credit. So I didn't want that to be a trick question. So make sure you go through all the solutions. They're posted on the website. One thing I noticed on the partial fractions question, remember when they're linear non-repeated factors, you can take the shortcut of just plugging in the zeros of those factors to get your A, B, and C. And so a lot of you were setting up a system of equations and solving the system of equations. That's not wrong, but that's time consuming. And the shortcut saves you a lot of time and you're less likely to make a mistake that way. So you might want to go back and watch my video where I talk about linear non-repeated factors and I talk about that shortcut. I highly recommend it. It can, if a question like that came up on the final exam, that could save you some time that you could use on something else. So go back and look at that if you don't know what I'm talking about. And then the other concept question that was on the test that was identical to the class discussion question was that thing about using L'Hopital's rule on sine x over x as x goes to 0. Some people were not quite getting what the circular logic was. There was a lot of talk about how you need to prove L'Hopital's rule. You need something. It's not proving L'Hopital's rule. It's to get the derivative of sine. So look at my notes on that. To find the derivative of sine, to find that it is cosine, back in Calc 1, we needed that limit. We needed to know the limit sine h over h as h goes to 0. We also needed the 1 minus cosine h over h. Both of those we proved with a geometric argument on the unit circle using the sandwich theorem. If you go back to chapter, I don't know where that was, first couple of chapters of this book, we went through a lot of trouble to get those limits, just so we could get the derivative of sine. And then once you have the derivative of sine, everything else is pretty easy. But so we couldn't have used L'Hopital's rule because that limit arose in trying to find the derivative of sine itself. So that was the circular logic there. The material this week, you've got two sections, 10.3. You're going to be seeing how there's this connection between the improper integral out to infinity and an infinite sum, and that we can kind of port over some of our knowledge of improper integrals to series. This is an important idea, that connection, so make sure you understand when it's true. It's not always true, but if for the right type of function, so make sure you understand that it has to have certain criteria to be true. We also talk about error bounding in there, which is important. A lot of people don't catch on to the fact that if you're going to actually be finding infinite sums for some practical purpose, more than likely you're just going to be approximating, having a computer add up a whole bunch of terms. But you need to know how good that approximation is, and so it's important and nice when you have some sort of truncation error theorem for the series you're working with. And we can do that with these series that could converge because of the integral. And then also we will revisit DCT and LCT. So those tests on integrals, as you might expect, since there is this close connection between integrals and series, the DCT and LCT can actually be ported over to series as well. And so if you were, that'll give you kind of a second pass at those. I know when we see them the first time for integrals, it might be a little awkward for people. So you'll be really doing the same thing, but with comparing sequences as opposed to functions, to make an argument about series as opposed to integrals. So that's what we're looking at this week. As always, be reading the book, watching the videos, do those quizzes as if they were real test questions. You can always go back and then check your work against your notes and stuff, but I would take it the first time as if it was like an in-class quiz, like we were in a face-to-face class. That'll help test yourself to see if you're ready to move on to the next section. Know you've really got it. And whatever else, I forget where I was. Discussions, watch the videos, read the text, do the homework, just do all the stuff. None of this stuff is busy work. You really have to do those homework problems to develop the intuition. The quizzes are there to check yourself on see how you're doing, and the videos are there to provide the content. So none of those pieces is designed to just be busy work. I feel like that's the bare minimum you need to get by. So make sure you're doing that stuff. And as always, let me know if you have any questions.